Okay. Yesterday we have seen data declaration. Data declaration. I'm taking variables and we declared pointer variable and assigning the address. This part is completed. Now, how pointers will work with arrays? How the pointers will work with arrays? Okay. So here I'm taking one array. Here I'm taking one array. So the array size here I'm taking total int a of 5 equals to 1 comma 2 comma 3 comma 4 comma 5. I'm closing it, semicolon. So here each and every element is a of 0, a of 0, a of 1, a of 2, a of 3. So this is I'm calling it as a of 0. This I'm calling it as a of 1. This I'm calling it as a of 2. This I'm calling it as a of 3. This I'm calling it as a of 4. Now the topic is array, how the pointers will work with arrays. Now we are discussing that. So a of 0 is nothing but 1. A of 1 is nothing but 2. And this is 3. And this is 4. And this is 5. And what is the pointers? In the last class we have seen that through address we are reading the value. Through address, but here there is no addresses. Every array having lot of elements. So these are the order a of 0, a of 1. So every array having address also. So that is 65002, 65004, 65006, 65008. How these addresses are calculated? How these addresses are calculated? Let us see the formula. Let us see the formula. How these addresses are calculated. So what is the formula for this?
Is a 2
L
bytes.
Yes, element address equals to base address plus index into size of dt for data type. So it means I want to calculate the first element address. It means address of a of 0 is equals to base address. What is the base address here? For every street, for every home, for in order to visit any other things, there is a base address. So when you created this array, base address, suppose I am taking 65000. Plus, consider my base address is 65000, starting address when I created that array. What is the index here? 0 into size of data type, how much? 2 bytes. So total how much value you will get? 65000 you will get. 65000. Let's calculate second element address. Address of A of 1. Address of A of 1 is nothing but base address is 65000 and what is your index here? 1 into 65002. Like that, one more address. A of 2 equal to base address plus your index is 2 into 2 how much? 4. So like that, one more address A of 3. So how these all addresses are calculated, that I am telling now. 3 into 2 how much? 6. Next address is 8. Next address is what here? 8. Okay. So this is a formula to calculate the number of addresses. Again, I am telling element address equal to base address. A base address plus size of index into size of data. Base address is very important here. Base address is very, very important. Base address is nothing but when I created this one in the from the memory having lot of addresses. In that address, they will choose one address. From that address, they will use it to store the that what is it? To store the elements from that location. Okay. So yeah, what is the first address? 65000, 65002, 65004, 65006, 65008. So according to our concept, pointers is nothing but what are the steps I told you? Data declaration, first step. Data declaration is the first step. Second step is what? pointer variable declaration. Yes, pointer variable declaration. Third step is what? Pointer variable declaration. Third step is what? Assigning the address. If you know these three steps, your pointers variable pointers is completed. I told yesterday. So yesterday we have seen arrays with variables. It is completed. Now arrays. This is arrays. Yes. Now data declaration is successfully I declared here. Successfully I declared here data declaration. It consists total 5 elements. An array having 5 elements with continuous memory allocations. With continuous memory allocations. Now what is our second step? Pointer variable declaration. So here, what we will write here? Int pointer p semicolon. Okay. So this step also completed. This step also completed. What it means? You are created one pointer variable p. You are created one pointer variable p. So in this p variable, now you are going to assign the address. Once again. Yes. Yes, I created one array. Data declaration is completed. Pointer variable declaration is completed. Now, what is the assigning the address here? What is mean by assigning the address here? Assigning the address means students. Suppose if you write here p equal to address of a of 0. So what it means? You can store only single element address 65000. So it will points to only one address. This address and it will points to this. If I write here pointer p equals to 65000. If I write pointer p here, your value will be 1. So here what I am doing here? I am storing individual array element address. Individual array element address. Address of a of 0, address of a of 1, address of a of 2, address of a of 3, address of a of 4. Individual array element address I am storing. But this is it is again same as to your that variable address only. But what is the difference here? So try to understand a very important point I am telling now. Very important point I am telling now. The point is base address is equals to first element address is equals to array name. Try to understand this. Just analyze this in this particular diagram among this all the screens. What is the base address here? 65000. What is your first element address? 65000. What is array name? What is array name here? A. Your array name here is what? A is equals to A. A array name is what here? A. A equals to A. This all indicates the address 65000. Try to understand. If I ask you what is the base address 65000, if I ask you what is the first element address 65000, if I ask you what is the array name itself is the address, students. In A of 5, students, in A of 5, this whatever the A is there, whatever this A is there, called as itself we can call it as address, base address. Now here what I will store now here? What I will store now here is base address A semicolon. Now P storing what here? What P storing? 65000. So when you stored base address, When you stored base address, it means students, when you store base address, it means you can point out to the any value. You can point out to the any value. It means students, simple, very simple. So what this, 1 second. I'm writing here, okay. So here, sorry, here, okay, here some mistake, not P here. This is E. This is P. P equals to here. Just try to understand. This one will give you lot of definitions, lot of definitions it will give you. Now, one more definition is came, that is P equals to A. So these all the values, whatever the values here it is there, these all are belongs to only one value 65000. If I ask you what's the base address 65000, if I ask you first element address 65000, if I ask you array name 65000, what is P? P also holding what? 65000 only. Now the scenario, see, this one you can call it as 65000 ఉంది కదా, మనం దాన్ని ఏమంటాం, అడ్రస్ ఆఫ్ A of 0 అంటాం కదా, ఓకే. And this one address of A of 1, this one address of A of 2, this one address of A of 3, this one address of A of 4. Now A అంటే ఏంటి, ఇక్కడ అరే నేమ్ కాదు, ఇప్పుడు అరే A అంటే ఏంటి, అడ్రస్, బేస్ అడ్రస్ ప్లస్ 0th ఇండెక్స్. It means this value 65000 value. Next A plus 1, next A plus 2, next A plus 3, next A plus 4, next, so A and P both are same, P plus 0, P plus 1, P plus 1, P plus 2, P plus 3, here P plus 4. సరే రైట్ సైడ్ ఇవన్నీ ఏంటి అంటే, ఈ రైట్ సైడ్ ఇవన్నీ ఏంటి, అడ్రసెస్ అన్నట్టు, వాల్యూస్ కాదమ్మా, అడ్రసెస్. అడ్రస్ ఆఫ్ A of 0 అని అనుకోండి, వాట్స్ యువర్ వాల్యూ 65000. A plus 0 అంటే కూడా ఏంటి, 65000. A plus 0 అంటే ఏంటిది, బేస్ అడ్రస్ ప్లస్ 0th ఇండెక్స్. So P also holding base address plus 0th index, base address plus third index, base address plus third index. So these are all the values. Coming to the left side, what is A plus 0? 65000. If you keep here pointer, so this is the value of, okay, A plus 1 ante address, pointer A plus 1 ante ఏంటిది, అడ్రస్ లో ఉన్న వాల్యూ. A plus 2 ante ఏంటి, అడ్రస్. So what is this value, A plus 3, A plus 4, ఓకే. A plus 4 అంటే అడ్రస్, రైట్ సైడ్ ఇక్కడ అబ్జర్వ్ చేయండి, A plus 4 అంటే ఈ అడ్రస్, పాయింటర్ A plus 4 అంటే వాల్యూ. నెక్స్ట్ P plus 0, నెక్స్ట్ what you will keep, pointer P plus 0 is 1, pointer P plus 1, 2, 3, 4. అన్నిటికి ఏమంటారు మనం, పాయింటర్స్ బెటర్, మర్చిపోయాను, కీప్ పాయింటర్. ఓకే, స్టార్, here also star. And you can also call it as P of 0, P of 1, P of 2, P of 3. So like that. సో ఇక్కడ మీరు అర్థం చేసుకోవాల్సింది చాలా ఉంది స్టూడెంట్స్. ఈ ఒక్క 2 steps, ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ డోంట్ హ్యావ్ దీస్ 2 steps, there is no this one and this one. Only this simple array. Okay, when we have these two steps, pointer variable equal to I'm storing the base address is nothing but array name. అంటే ఇక్కడ మీరు అసలు ఎందుకు సార్ ఇదంతా డయాగ్రామ్ ఎందుకు సార్ అని మీకు అనిపించింది అనుకో, ఒకటే స్టూడెంట్స్, అరే ఎలిమెంట్స్ ని మనం ఎన్ని విధాలుగా కాల్ చేయొచ్చు. అరే ఎలిమెంట్స్ ఉన్నాయి కదా, 1 2 3 4 5 ఉన్నాయి కదా, వీటిని we can call this all the elements in many ways like this. Let us execute one code, you will understand it. Okay, let us execute this code. Okay, very simple code. Tell me what we'll write. Only two steps. What's that? Int a of 5. Int a of 5 equals to 1 comma 2 comma 3 comma 4 comma 5. Next, int pointer p. These three steps I'm not taking nothing. Okay, so I'm remove these all the elements. Okay, now I'm going to enter the scanf percentage d comma, what will write here? అడ్రస్ అంటే మనం ఏం చెప్పాను, ఇందులో మీరు ఏదైనా యూజ్ చేసుకోవచ్చు స్టూడెంట్స్. ఫర్ ఎగ్జాంపుల్ ఫస్ట్ ఐఎమ్ రైటింగ్ అడ్రస్ ఆఫ్ a of I semicolon. Okay, next I'm printing those elements in the output. Printf a of I. Let us execute this code. 1 2 3 4 5. వచ్చింది అవుట్పుట్. So in the place of this again, not address of a of I, I'm using a plus I. Here also I'm using pointer a plus I. See, 1 2 3 4 5. Again you got the output. So in the place of this, now I'm using p plus I. And I'm writing pointer p plus I. So what you are accessing this array, you are accessing this array with the help of these many address of a of I, a plus I, p plus I. So the like that you are calling, again it will come same output. Got it? So this is the array of pointers. This is about array of pointers. Gagan, take one screenshot of this. Send in group.
Okay, sir, please come.
ఓకే, గాట్ ఇట్. దిస్ అరే ఆఫ్ పాయింటర్స్. అంటే అరేస్ కి పాయింటర్స్ కి ఇంత పెద్ద రిలేషన్షిప్ ఉంది మనకి. సో దీని నుంచి చాలా క్వశ్చన్స్ వస్తాయి స్టూడెంట్స్, చాలా క్వశ్చన్ కంపల్సరీ. మీరు టెక్నికల్ లోకి వెళ్తే కంపల్సరీ దీని నుంచి 2 క్వశ్చన్స్, గేట్, టెక్నికల్, సెట్, నెట్, అది ఏదైనా కానివ్వండి, ఇందులో నుంచి ఒక క్వశ్చన్ వస్తుంది డామ్ షూర్. కంపల్సరీ 1 క్వశ్చన్, 2 క్వశ్చన్స్, 3 క్వశ్చన్స్. ఓకే, నెక్స్ట్ కమింగ్ టు ఇన్ దిస్, ఐ విల్ ఆస్క్ యూ సమ్ క్వశ్చన్స్. ఇన్ దిస్ యూ టెల్ మీ ద ఆన్సర్. Suppose I am having the values like 1 2 3 4 5. So see, what is a pointer a plus 0? 1. Pointer p plus 0, 1. What is the value of pointer a? Pointer a also 1. Pointer p also 1. Why? A means what? 65000, same address. Pointer a is nothing but what? 1. P is nothing but also 65000. Pointer p also what? 1. So again, just try to understand. A, P, these are all same. Next, we are going to discuss about last one. How structures will represent this. Now structure. Or the structures. Okay, this is structure. Let us draw the one diagram for this. So these are the structures. These are structure elements. So total int age, float average, and these are structure. So what is our structure variable here? S1. S1, and here how many variables here? S1 is the structure variable. In this we have total 3 elements: name, age, and one more is average. So this is the name, age, average. Okay, what is the address of this? Consider address of this is 65000. Now see what happened now. Now see what happened. Now I'm going to write one main function code. I'm going to know one main function code, void main. So already we discussed about structures in the last class, right? So struct student S1 equal to ABC 12 1.1. Student lo unna 3 properties, name, age, average will be assigned to the S1. So S1 having 2 informations, 3 variables. So this is a ABC, and this is 12, and this is 1.1. Okay, 1.1 I am taken. Now in this, this is 1.1. Let us see here. Now let us see this one. Here I am writing main function. Main function. Okay. So here, what I'm writing is here what I'm writing is I'm taking one pointer variable p. It should points to student structure. Student structure. Because previously you used to write int pointer p, float pointer p, character pointer p, like that you are going to write. But here you are going to create one pointer variable p. So this pointer variable is storing some address. This address should points to where? This address should points to where? Student. 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 What student consists of? It is a type of structure. It is type of, that's why we should declare like this compulsory. P is a pointer variable. So this in this pointer variable, in the next step I am writing p equal to address of S1. Try to understand. First in the first one, p equal to address of X, q equal to address of A we taken while variables. Coming to arrays, we taken p equals to A only, array name. But coming to here, we are storing the address of the structure variable. Address of the structure variable S1. So what it means? It is storing 65000. So whatever the address you are stored in this, so this address is pointing to where? One structure. It is one structure. What is the type of the structure? Student. Student. Pen having different values. Book having different structure elements. Employee having different structure elements. Whatever the address I am storing, that should be point out to student structure. So that is the meaning of this. That is the meaning of this. Now let us see. Let us solve this all. Okay. Here one diagram. Here one diagram. Here one diagram. Okay. Initially, you know very well that initially we are using dot operator. S1 dot name equals to ABC directly written. Okay. You know very well about this. Next one, S1 dot age equals to 12. Okay. You know also this S1 dot average equals to 1.1. Now pointers. Pointers. P is nothing but what? Address. Pointer P is nothing but what? In that address. How many variables are there? 3 variables. A, B, C. Next, P is nothing but what? Address. Pointer P is nothing but in that address. Total 3 elements are there. In that age equals 12. P. Pointer P dot average equals to 1.1. And this is you can call it as using dot operator, how you can access structure elements. So this is by using pointers, by using pointer, and this is we can call it as indirect selection ఆపరేటర్. ఇండెక్స్ సెలక్షన్ ఆపరేటర్. ఇండెక్స్ సెలక్షన్ ఆపరేటర్ అంటే ఏంటి అంటే అది ఎలా ఉంటుందంటే ఇలా ఉంటుంది. మీరు డేటా స్ట్రక్చర్స్లో ఎక్కువ యూజ్ చేస్తారు దీన్ని. ఇలా ఉంటుంది ఆపరేటర్. సో ఈ ఆపరేటర్కి లెఫ్ట్ సైడ్ మనం ఏం యూజ్ చేయాలి అంటే పాయింటర్ వేరియబుల్ యూజ్ చేయాలి, పివి. రైట్ సైడ్ ఏం యూజ్ చేయాలంటే ఎస్వి యూజ్ చేయాలి, అంటే స్ట్రక్చర్ వేరియబుల్. ఇప్పుడు ఈ అమాంగ్ దిస్ ఆల్ ఇందులో మొత్తంలో ఏది స్ట్రక్చర్ వేరియబుల్, ఏది పాయింటర్ వేరియబుల్? స్ట్రక్చర్ వేరియబుల్ వచ్చేసి S1, స్ట్రక్చర్ ఎలిమెంట్స్ వచ్చేసి నేమ్, ఏజ్, యావరేజ్. పాయింటర్ వేరియబుల్ వచ్చేసి అంటే పి. అంటే దీని మీనింగ్ ఏంటి అంటే లెఫ్ట్ సైడ్ పాయింటర్ వేరియబుల్ పాయింట్స్ టు నేమ్ ఈక్వల్స్ టు ఏబిసి. నెక్స్ట్ పాయింటర్ వేరియబుల్ పాయింట్స్ టు ఏజ్ ఈక్వల్స్ టు 12. Pointer variable points to average equals to 1.1. So there are three ways we can access structure elements. When you use pointers, three ways we can access structure elements. The first one that is dot operator. Second one that is pointer variable. First one that is dot operator. Second one that is pointer variable. Third one that is indirect selection operator. Indirect selection operator, students. So three ways you can access these elements. Three ways you can access these elements. Three ways you can access these elements, students. Okay, three ways you can access these elements. Now how pointers with structures is completed, pointers with arrays also completed. Now we'll see how the pointers will work with functions. How the pointers will work with functions. Let us see the problem. That also we'll see. Now it's gone. Okay, okay, no problem. For example, I'm writing one code here. Void main. Okay, here I'm taking total two variables, int x comma int y. I'm calling one function, change or something, sh or mod function, modify function. I'm taking modify. I'm passing here address of x comma address of y. Okay, completed. Here I'm displaying printf %d comma x comma y. Okay, next I'm taking here modify function. Modify function here I'm taking into pointer p comma into pointer q. Here I'm taking one more variable. That variable I'm calling it as here I'm writing pointer p equals to 1, pointer q equals to 2. Yes, this is the problem. sorry. Okay. So this is a calling function and this is a called function. So in calling function, there are two variables, x, y, and these are respected addresses, this line. And here also two variables, p and q. This p and q, both the variables, if you store some address in p and q, these values, these addresses will go to integer values. Yes, here p variable I declared, q variable I declared. So I told you students, this is about the p, the q. So here this is a calling function and this is a called function. Here you're calling this function here, modify. So what is address of x here? Address of x will be stored in p. Address of y will be stored in q. It means here the value will be stored 65000. Here the value will be stored 65001. 2. So when you store respected addresses, first of all, I'm going to clear again. I am telling the actual parameters. Actual parameters you are passing here addresses, not values. When you're passing addresses here, there is a variable. It should be pointer variable. It should be pointer variable. It should be pointer variable. When you declare here pointer variable, in this pointer variable, which address is stored? Address of x. In this variable, which address is stored? Address of y. Yes, p equal to 65000, q equal to 65002. Now, when you store like this, automatically these two are connected. Connected is not a joke here, students. Calling function, called function now connected to which function? Called function is connected to which function? Calling function. One function, other function communicating each other. Here pointer p equals to 1, pointer p equals to 2. What is a p? 65000. What is a pointer p? In p is nothing but 65000. So in this address, now you have to store one value. Q is nothing but what? 65002. In this address, you have to store which value? 2 value. So that's it. That's it. That's it about functions and